We are the students of VNIT Nagpur. Our project is eCAD, eClinic and Automated Dispensary. Major components: BeagleBone Black, TIIC series launchpad, LM35 CAZ temperature sensors, buzzer, stepper motor, display unit, and Max 232 lever shifter for GSM module. We have used a tab as display unit for the app, whose output signal is given as coordinates to BeagleBone, which enables the TIIC series accordingly. The GSM module for sending reminder to the patient. Stepper motors. We have used 4 bidirectional stepper motors to show it as a prototype, which are controlled by the TIIC launchpad. There are aluminum coils connected to these stepper motors, which will be used to transform the rotational action into translational. In a country like India, which stands 112th on the scale of healthcare facilities, where the availability of doctor in rural areas itself is a challenge, it will not be very surprising that the basic medicines are not available to them, especially during the emergency or at the odd hours in the night, say after the working hours when all the stores get closed. Also in the urban areas, due to such a high population density, many times there are huge queues at the medical stores. Even for the non-prescribed medicines, people need to wait unnecessarily for a very long time. Also, on the highways, say on a long road trip, if you get sick, even if it's a minor headache or fever, it becomes a big problem. To overcome all these problems, the eClinic and Automated Dispensary will ensure the 24/7 availability of the medicines. Apart from dispatching the medicines, it checks the body mass index of the user and sends regular reminders for the medicine intake.
The basic idea is to provide an automated dispensary with eClinic to help people 24/7. The motive is to avail basic medical facilities to common people by eliminating the role of distributors, hence making it both ethically and economically feasible. This system is, if commercialized, would help in bringing down the prices of medical products, thus making it accessible to poor and needy. This flowchart explains working of our system. We have used BeagleBone Black as our main processor, which communicates with TIIC board to drive stepper motors, which in turn drives aluminium coils. These aluminium coils are responsible for translatory motion of our medicine strips, which are dispatched to outlet of our system. This is our first temperature sensing unit. We have used LM35CAZ as a temperature sensor from Texas Instruments. We have used OPA227P as operational amplifier to amplify the analog values of this sensor. This unit is installed in interior of the system to get temperature of interior of the system. This is another temperature sensing unit which is installed at exterior of the system. This will give the temperature of surrounding of the system. Our second TIIC board is connected to GSM 300 to send reminder to the registered users. TIIC board asks contact number of the registered users from main processor BeagleBone Black. This is our portable display and touchscreen, which provides graphical user interface through Android application, which is installed in main processor BeagleBone Black.
Now we are going to explain the basic idea of the user interface. When the user enters, he first has to enter his unique username and password. With right username and password, the user enters to the next screen where he has to select from either of medicines, checkup or consultancy according to his requirement. Proceeding further, if the user selects medicines, he can select from the available medicines according to his problem. If the user wants some general checkup, then he can proceed with the checkup option where he can find out his BMI by entering his height and weight. Else, if the user wants any consultancy, he can select the type of consultancy he wants from the available options.
It is assumed that the user is registered already in the database, hence his details are already with us. Now I will show a demo of the operation. I will enter login and password. Now I have to choose among medicines, checkup and consultancy. Now I am selecting medicines. I have to select any one of the options below. Now I am selecting fever. I must select one of the available medicines. Now I select Crocin. By this selection, BeagleBone Black would get a value, which will be processed by the BeagleBone.
तूने नाम पे फोकस किया क्या? this is how exactly we did it.
Now we will explain how our internal circuit diagram of ECAD works. First we will start with the stepper motors which are connected to the motor driving circuit. These motor driving circuits are connected to the TIIC board which are connected to our main processor vehicle. Motion of the stepper motors are calibrated to rotate the required number of times that will dispense specified number of medicine steps. Calculations are done keeping in mind 2.2 cm radius of the pulse. Now I will explain the connections of the GSM module for the reminder system. Here the level shifter circuit using MAX232 IC is used for the serial communication of the TIVA microcontroller and GSM module SIM300. The circuit translates between 0 to 5 volt TTL logic level voltages to plus minus 12 volt levels required by the RS232 on the GSM module. The TIVA microcontroller is programmed to give the proper AT commands at proper timings required for the working of the GSM module. This will send the reminder for the medicine consumption on scheduled time, which will ensure the correct dosing of the medicine and will send the appropriate message to the user's number stored in the database. If the transaction of the medicine is done, then the message A plus the number will be sent by the programmed TIVA microcontroller to the GSM module, and the GSM module then send the message to the mobile. And if the reminder is to be sent, then the message B and the number will be sent to the GSM module by the programmed TIVA microcontroller, and it is sent to the mobile.